Hello, welcome. Today we are going to be starting with carbon and its compounds. Please, if you like our videos, hit the subscribe button by this side of your screen. Always share our videos so that your friends can see them. If you like our videos, please like them. Carbon is a non-metal. It is a member of the group 4 elements on the periodic table. It exhibits oxidation state of +2 and +4 in its compound. The pure element rarely occurs naturally, and it occurs as diamond or graphite, but it occurs as coal in the impure form, which is very common. It also occurs combined with other elements such as oxygen and carbon 4 oxide. Also occurs combined with elements such as hydrogen in natural gas, as in methane. It occurs mostly in compounds like triisocarbonate 4, as in limestone and chalk, to the wide variety of organic chemicals, which include hydrocarbons, plastics, as well as fats and proteins. It also forms an important source of fuel. Most of the carbon compounds are studied as a separate part of chemistry called organic chemistry. Organic chemistry is known as the chemistry of carbon compounds, other than the oxides and the triisocarbonate salts, which are the ones we are going to be considering here. So the compounds of carbon that we are going to be considering in this series is those of the oxides, the various carbon oxides, and the triisocarbonates. But the other compounds of carbon will be studied under organic chemistry, which is another series in this our presentation. Now let's look at allotropes of carbon. The ability of carbon to exist in various forms in the same physical state is known as allotropy. Diamond and graphite are two allotropic forms of crystalline carbon. The others like coal, coke, charcoal, lamp-black, sugar charcoal, and animal charcoals, are amorphous or non-crystalline forms of carbon. Carbon can exist in three different allotropic forms: diamond, graphite, and amorphous carbon, that is, shapeless powdered form carbon. Each of the forms is called an allotrope of carbon. They all consist of the same element, carbon, but they have different physical properties with respect to shape. So allotropy simply means shape or forms in which carbon can exist in, but at the same time having the same physical state, because all of them are composing of the same elements known as carbon. But this time around, they exist in different forms or shape. Example is diamond and graphite, which are crystalline and pure in nature, whereas other example, non-crystalline example, are considered as amorphous carbon. Now let's look at diamond. Diamond is the purest form of naturally occurring carbon. It is found as colorless, lusterless solid. Diamond has the shape of an octahedron, that is, eight-sided figure. The carbon atoms are joined together by covalency. All the four valency electrons are used for bonding. Graphite. In graphite, the carbon atoms are arranged in layers made up of hexagonal rings with spaces in between the layers. The in-between spaces of the layer structures are railed interstitial spaces. The bonds between the carbon atoms in the ring are strong. The layers are held together by van der Waals forces. These weak forces allow movement of the plane parallel layers of the plane parallel to each other. Uses of graphite. Because of the slippery nature, graphite is used as a lubricant in engines where high temperatures will melt ordinary lubricants. It can be used in the manufacture of lead pencils when mixed with clay. It is used as an electrode in electrolytes. It is used as a black pigment in paints and as a neutron moderator in atomic powers. Physical properties of graphite. It conducts electricity. It writes well on paper. It has density of 2.3 gram per cm cube. It is a soft black material which feels greasy to the touch. This is where we're going to be stopping. In subsequent classes, we'll look at the compounds of carbon. Please hit the subscribe button here to subscribe. Thanks and God bless you.